students. In today's video, second year topic 12th standard naming coordination compounds. I am going to discuss. I have written some points here students to save the time. Name of ligands. Some naming of ligands, neutral ligands, negative ligands, positive ligands, all I had given. Neutral ligands. See first one NH3, what we call it as amine. AMMINE, amine spelling important. Why? Because one M you miss also, you lose the marks. Next, water, aqua, what we call it as aqua. Next, NO, nitrosyl, CO, carbonyl, CS, thiocarbonyl, O2, dioxygen, CH3NH2, methylamine. Next one, this is dioxygen only, methylamine, dinitrogen, this is pyridine, this is urea, thiourea, like this it will come. So only these names, little changes is there. This is ammonia means amine we are calling, water means we are calling aqua, but these are same name, same. It seems to be dioxygen, writing also dioxygen, methylamine, there is no issue this side, but this side a little problem. What is this? Ammonia generally we are calling, but here calling amine, letter, one letter you will miss also, lose marks students. Aqua, nitrosyl, carbonyl, thiocarbonyl, like this. Now this is neutral ligands. Next one, negative ligands. Negative ligands F minus, yes, fluoride, generally we call it as fluoride. Instead of E, O you can write, that's all. Fluorido, bromido, chlorido, I minus, H minus, hydrido, N3 minus, nitrito. Next, azides, N3 minus we call it as azido, NO2 minus, nitrito. But NO2 is ambident ligand, right or not? Ambident ligand, and CN also ambident ligand. Suppose here NO2 minus is there, nitrito through N, nitrogen linkage means N, oxygen linkage means nitrito O. Next, OH minus, hydroxo, O2 minus, oxo, O2 2 minus, peroxo, CH3COO minus, what we call it as acetate2. So like this we are calling. This is negative ligands. Okay. Next, naming positive ligand, NO plus, generally asking questions, NO plus, nitrosonium, NO2 plus, nitronium, this is hydrazinium, hydrazine is nothing but NH2, this is hydrazinium, and this is anilinium ion, anilinium, like this. Okay students, now we will go to the examples, then I will cover more rules. See students, first we have to calculate oxidation state of central metal atom. We have to calculate oxidation state of central metal atom. Rule I am writing, oxidation state of central metal atom. Central metal atom. See, first we will calculate. This is 4. Each potassium plus 1. 4 into plus 1 plus ion, you don't know, take it as ion, that is only central metal atom, right or not? So here plus 6 into minus 1, cyanide equal to minus 1 charge, that is equal to the 0, equal to the 0. So 4 plus Fe minus 2 equal to 0. Then Fe equal to how much students? How much it is? If you bring this side, plus 2 oxidation state. So plus 2 oxidation state. So point 1 completed. Point 2, first we have to write cation complex. First we have to write cation complex, then anion. Then anion. See students, here this is potassium. This is positive complex, cationic complex. We have to write cation first, then we have to write this is anion. This is 4 minus. How it can ionize 4K plus FeCN6 4 minus. This is anion complex. This is cation. Okay. Now next one, third point. Third point. So negative complex. Negative in anionic complex. 1 second. Yes, we'll write here point. What is the point? Metal end with 8 in anionic complex. anionic complex. See here, this is metal now. This is positive, generally we are writing, but this is ion. This ion is coordinated with the negative complex, no, negative complex. That's when you don't write ion here. What is this? We call it as ferrate. Ferrate, Latin name we are writing. I will write the name, you will come to know. This is what first we have to write. First we have to write cation, right? Potassium. You need to write tetra potassium. Because of potassium only we have got oxidation state is +2. That's why specially you no need to write tetra potassium. Next one you can write next ligand. First cation you can write, then you can write ligand. What is the rule for ligand? We have to write ligands, we have to write. If ligands, only one ligand is there, no problem, you can write. So what is this? Already we have studied in first year also organic chemistry. In first year organic chemistry also we have discussed. 1 means mono, di, 2 means di, and 2 means di, 3 means tri, and 4 means what is this? 4 means quad, 5 means pent, not quad, tetra you can take it. 4 means tetra, and 5 means penta. Like this we are taken, right? 6 means hexa, like this it will come. But here only one ligand is there, no problem, you can write. So first cation, next anion complex I am writing. An anion complex writing, first we have to write ligands. Potassium, hexacyano, okay, ferrate ends with 8. So metal end with 8 in anionic complex. This is rule 3. So, and what is the oxidation state, students? Oxidation state is 2. We have to write with Roman number. 2. That's it. So first cationic complex we have to write, next anionic complex we have to write. While writing anionic complex, first we have to write ligand hexacyano. How many ligands here? 6 ligand, that is cyano, hexacyanoferrate. Okay, now come back to this one. So this is what is the oxidation state? Calculate oxidation state. 3 into plus ion, 6 into -1 equal to 0. So then 3 plus ion minus 6 equal to 0. Then ion equal to +3, oxidation state. Here +2, here +3. This is ferrate 2, this is ferrate 3, it will come. This is cationic complex. This is anionic complex. Cation write first. Potassium. Next tell me, students. Hexacyano ferrate 3. Try to understand. Ferrate 3. That's it. This is the name. Okay. Now potassium ferrocyanide we have studied, no? That is common names. This is IUPAC name. Hope everybody clear this one. Now come back to this one. Different examples I have selected, students. Each example time one new rule I will introduce. Okay. See here. This is cationic complex again. This is anionic complex. Okay. Calculate oxidation state first. 3 into +1 plus X. What is X here? Chromium. So oxalate ion is bidentate ligand. Oxalate ion is bidentate ligand. So bidentate ligand, already coordination compounds videos I have done. Go through that. Bidentate, hexadentate, all ligands I had explained. 3 minus 2 equal to 0. Okay, that's it. So 3 plus x minus 6 equal to 0. Then x equal to +3. What is x here? That is chromium. Chromium equal to +3. So can you try this name, students? How to give? Next, first write down the cationic complex. Potassium. Yes. Potassium trioxalato. What is this? Oxalate. Oxalic acid. Oxalato. Trioxalato. Next, what is the name? Chromium or chromate. What we have to write? This is anionic complex, no? Anionic complex is nothing but it ends with 8. Chromate 3. That's it. Chromate 3. Clear? Now, next one. COCl2 En twice Cl. See here two ligands is there. Two ligands is there. This is cationic complex. This is cation. This is anion. Cation, anion. See note point students here. I have two types of chlorine. I have two types of chlorine. Inside the chlorine we have to write chlorido. Outside it is end with what is this is negative ligand, no, end with 8, chlorate. Okay, so inside chlorine we are writing chlorido, outside chlorine we are writing chlorate. Okay, keep it in mind. Now try to give the name students. This one what to write here, two chlorines. Here also en is nothing but ethane 1,2-diamine. Ethane 1,2-diamine. Here 2, here 2, here 2, here 2. That is the reason to avoid this confusion. One we are writing di, one we are writing bis. One we are writing. 2 means generally we are taking di, and 3 means tri, and 4 means what is the students? 4 means tetra, and 5 means penta. Like this we are taking, right? So but here two times 2 chlorido, again you are writing 2 ethane di, this is dichlorido we are writing. Here also writing di ethane 1,2-diamine, confusion. That's why to avoid this one, two times if it is repeated we are calling here one more name bis. This is tris, this is tetrakis. Like this it will come. Okay, now we'll write the name. Now try to understand. This is cationic complex. First calculate oxidation state students. How to calculate oxidation state? This is -1, this is +1, right? So what is this? Cobalt plus 2 into -1, 2 into -1, this is neutral ligand, this is neutral ligand. So plus 2 into 0 equal to the charge +1. You can write like this, or else you can write 2 into 0 plus 1 into -1 equal to 0. Like that also you can calculate. Both correct. Both the methods you can follow, any method, no problem. Final answer is correct. So equal to +1. Then cobalt equal to +3 oxidation state. Okay, now next one. So write the name. First we have to write cation. First we have to write cation, right? Write the cation. Cation complex we are writing. First what we have to write? Ligands we have to write. Ligand, two types of ligands is there. If two ligands is there, we have to follow alphabetical order. Alphabetical order. This is chlorido, C. Chlorido, C will come. And ethane 1,2-diamine. Ethane 1,2-diamine. So according to alphabetical order, who will come first? Definitely C will come first. That only we can write now. So first one what we are writing? Dichlorido. Inside chlorine, chlorido. Dichlorido. Next one what we are writing? Bis. Bis ethane 1,2-diamine. Ethane 1,2-diamine, close the bracket. 1,2-diamine, close the bracket. Then what we will write here? So then chlorate or chloride, what we have to write here? So that is anion, no? That is anion. So try to give the name dichlorido, bis ethane 1,2-diamine, cobalt. Yes. Next we are writing here. Okay, better I will write here only. Why? Because we should not give gap here. Yes, little bigger letters I am writing. Ethane 1,2-diamine. Then close the bracket. Close the bracket. Then you have to write this. You have to complete. No. What is this guy name in cation complex? Cobalt. What is the oxidation? Cobalt 3. And this is what we call it as chloride. Chloride. Okay, cobalt 3 chloride. AIDS will come. When it will come AIDS, so it is inside. That is central metal atom. We will write AIDS, but here chlorines means Slight change is there, students. What is that? Chlorines means inside chlorine we are writing chlorido, outside chlorine we are writing chloride. And 8 also will come. When 8 will come, metal atom, central metal atom, anionic complex, ends with anionic complex, then we are writing 8. So this is the name. Now next one, this one, nickel carbonyl. Generally we are calling nickel carbonyl. What is the IUPAC name, students? Try to understand. In all carbonyls, what is the metal oxidation state? In all carbonyl, metal oxidation state is 0. So then we can write tetracarbonyl. What is this? Nickel. What is the oxidation state? 0. What is the oxidation state here? 0. Nickel 0. Nickel 0. That's it. Okay. Simple this name. Now next one. Sixth one I am taking here. Try to understand. Try to give the name. NH3 thrice, NH3 3 times, and the next H2O 3 times, H2O 3 times, and next one, what is this? Cl3. So now see, this is cation, this is anion. Cation, anion. How many types of ligands? This is amine ligand, this is aqua ligand. See, this is amine, NH3 is amine, and water is aqua. Right or not? Who will come first? A letter matching. Then second letter you can see. M, this is Q. Who will come first? This one. Okay, next chromium. What is the oxidation state? This is neutral ligand. This is neutral ligand. How simple it is calculating oxidation state you can see. Outside 3 chlorines. Each chlorine is -1. Each chlorine -1. This is -3. This is +3. So in neutral ligands case, then what happened? What is the central metal atom? Here chromium, same oxidation state. No need to calculate. Now try to write the name, students. Try to write the name. First what we have to write? Ligands. Amine. We are writing amine first according to alphabetical order. Amine will come first. Next, triamine, triaqua, chromium. Next, what is the oxidation state? 3. Outside chlorine, just now I said no. Right. Chlorido inside, outside is chloride. That's it. This is the name. Now, next one. One different example I am taking. Ag, NH3 twice. Ag, NH3 twice. Next, Ag, Cn twice. Cn twice. For this naming they are asking. Here 2 central metal atoms, 2 complexes there. Definitely one is neutral, one is charged one. This is a neutral one. So this is cationic type, this is anionic type. Cation will come first, anion will come next. But calculate oxidation state. How to calculate oxidation state? Silver, you don't know, no? X plus, this is neutral ligand, 2 into 0, plus this is again X, plus 2 into each cyanide, what is the charge, students? -1. 2 into -1, that is equal to the 0. So X plus 2X plus 2X minus 2 equal to 0, then 2X equal to plus 2. So each atom is plus 1. Each atom is plus 1. That's it. What is the metal atom here? What is the metal atom? Silver. That's it. Like this we have to calculate. +1 oxidation state. Clear? Now write the name. One, you have to write the normal name. One, you have to write the Latin name. First again we will write cationic complex, then anionic complex. Right? First name, diamine. What is this name, students? Diamine. 2 times, no? 2 times. Diamine. Yes. What is this normal name? Silver. What is the oxidation state? 1. So each metal atom plus 1. Silver 1. Dicyanide. Cyanide. cyano generally we call it as, but it is negative complex, no, negative complex, no, it's with cyanido, we'll write cyanido. And next to Latin name, we have to write this one metal normal name, one metal Latin name. What is this? Argentate, argentate, that's it. Argentate. What is oxidation state? 1. This is oxidation state is 1. Clear, students? That's all. How easy it is. Now, next one more question I am giving. Try to understand, try to give the name. Now, what is this? 8th one. Example 8. Example 8. Cobalt NH3 5 times, NH3 5 times, then CO3, this is carbonate, CO3. And what is the oxidation state here? What is the oxidation state here? Cobalt, again 3 will get C. Here this is neutral ligand, NH3 is neutral ligand. Cobalt, what is this? Carbonate. Carbonate, what is the charge, students? Carbonate is -2 charge and chlorine is -1 charge. You can calculate like this. This is -1, this is +1. What is the oxidation state? Cobalt into 0 plus 1 into -2 equal to +1, equal to +1. That's it. What is the oxidation state? You will get on. What is the oxidation state? You will get answer here, students. Yes, cobalt, cobalt, yes, -2 equal to +1. Then what is the cobalt oxidation state here? 3. Cobalt equal to +3 oxidation state. Completed. Now we have to write ligands first. Ligands first, then central metal atom. First anionic complex we are writing, no? Sorry, first we are writing cationic complex, no? So write the name. What is the name? Yes, pentaamine, pentaamine, amine. Two times we have to write MM. One letter you missing also, miss the marks. Pentaamine. Next one, carbonato, 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 carbonato. Next one, cobalt. We have to finish off this one, no? First this ligand, next this ligand. Why this ligand? According to alphabetical order, A will come first, then carbonato. Cobalt, yes, cobalt. What is the oxidation state? 3. Then it is, that's it. Okay. Now next one. Next, 9th one. K, potassium. Again I am giving K2 Zn OH4 hydroxo. Given names, no? Okay, now try to give names, students. This one, potassium. What is the oxidation state of Zn here? What is the oxidation state of Zn? Potassium. What is the potassium oxidation state? +1 oxidation state, right? +1 oxidation state. This is 2 into +1 plus Zn into +4 into -1 equal to 0. Okay, +2 plus Zn -4 equal to 0. Then Zn equal to +2 oxidation state. Calculate oxidation state. Calculated, completed. Now what is the next point? We have to write the cationic complex first. Cationic complex first. Then write potassium, potassium, potassium. Next, tetrahydroxido. How many times here? 4 times. Tetra. What is this? OH minus. What we call it as hydroxido. Tetrahydroxido. Next, what is this? We call it as zincate 2. Hydroxido, zincate 2. That's it. This is the name. So with this maximum points I have covered, students. Now next video I am going to do bridging compounds. Sometimes they will give bridges also. Bridging nomenclature of coordination compounds also I am going to explain in the next video. Thank you students. Thanks for watching. Prepare well for examination and please make a note all this and prepare well. Thanks for watching once again.